Differences of squares. So previously we looked at perfect square trinomials. This time we're going to look at something that's close but a little bit different, and importantly different, which is that the signs in the two binomials are identical except the sign between the two terms are opposite. So let's go ahead and FOIL this out. If I FOIL this out, I get x squared minus 3x plus 3x minus 9. And what I see is because those signs were opposite, these middle terms cancel out, and I'm left with x squared minus 9. Well, this is what we call a difference of squares. Because x squared is obviously a square, and 9 is a square. So I have two things that are squares being subtracted. So that's called a difference of squares. So a polynomial of the form a squared minus b squared is called a difference of squares. And these can be factored quickly, very quickly, but you have to remember the pattern. And the pattern is a plus b in the first bracket and a minus b in the second bracket, just like we saw on the previous page. So let's take a look at the example here. 81x squared. Well, the question is, if you see something that looks like this, are these two terms squares? Well, 81, yeah, that's a square. That's 9x squared. And 1, is 1 a square? Sure, it's 1 squared. So if that's true, then we can factor this immediately as 9x plus 1 times 9x minus 1. That is my difference of squares method for factoring. And these questions can be very quick questions if you know the pattern. But just to confirm things, it's always a good idea to check. So check by foiling. So FOIL this, and we get 81x squared minus 9x plus 9x minus 1. And yep, we see those middle terms cancel, and we get left with what we started with, or what we had in the question, I should say. And so we can confirm that our difference of squares factoring worked for us. So in this question here, we're going to check, do we have the difference of squares pattern? Well, 4x squared is 2x squared, and 21y squared is 11y squared. So yeah, I have the difference between two squares, so I can immediately jump to my difference of squares solution, which is 2x plus 11y, and 2x minus 11y. And I'm done. Again, we could confirm this by foiling out those brackets. Last example I wanted to show you here. Let's first check by, we have two terms, they look like they could be squares, and sure, a squared b squared is just ab squared, and 64w squared is 8w squared. Oh, but this is a plus. It is not a minus, and to have a difference of squares, it has to be a minus between these two terms. So this is not going to work. It is not a difference of squares. Not a difference of squares. So just be careful with that. Always check to make sure that that sign between the two terms is a negative.